Hi everyone. My name is Jackie, and I'm currently doing my PhD in mechanical engineering, and I wanted to share like a little bit about my journey into robotics and autonomous system. And instead of giving a very technical research talks, I want to focus more on my path and what I work on. I know Brian reached out to me on LinkedIn, and I couldn't really reply him back, so I hope I could give him good advice and like talk to him more today. And some advices for like students who might be interested in robotics or engineering career. So this is agenda quick overview. I'll briefly introduce who I am, and I'll talk more about actually what I work on in research, robotics research. And after that, I'll share my journey, how I got into this field, and some experiences along this way. And finally, I'll share a few lessons and advice that might be helpful if you're interested in robotics or engineering. Maybe you want to get a job. Yeah. So this is who I am. Sorry, I prepared this presentation quick. So I'm doing my fourth year. I joined as mechanical engineer. Oh, it's like, yeah, a mechanical engineer. So my research focus on robotics and autonomous system, especially how multiple agents, so agent mean robots, so multiple robots can coordinate and move efficiently in complex environments. So my academic background is mainly in dynamics control. It's like dynamically unstable robot, and I'm controlling it. I'm trying to explain easily. But something that I personally enjoy a lot is building real robotics system and testing ideas in the real world. So I like working on projects where theory meets hardware. So I'm in between with the hardware hands-on stuff and software both. So throughout my research, I try to combine both algorithm deployment and hands-on system implementation. So this is what I actually do, what I worked on. So so in simple terms, my research focused on how robots can move intelligently and collaborate with each other. So this is one of my paper. So I was working with DevCom Army Research Lab. I was lucky to collaborate with them. So I was working three UAVs and one UGV. They're collaborating, and then this is for defense surveillance system. So they're like keep visiting, coordinate repeatedly in 72 hours. But here's the thing. So drone is really, so I've been working on drones, and they're really efficient in 3D space. But the downside is they are not based on fuel, so they need battery. But when drones want to like fly longer, they need higher capacity of battery. And when we want higher capacity, it's becoming heavier. So heavier means it cannot really fly longer. So for drones, battery problem is really important. So I try to work on like maintain how to recharge them or like swap the battery. Yeah, that's my topic of research. So so I work on problems where multiple drones and ground vehicles need to plan their paths efficiently while completing certain tasks. So this involves areas like planning algorithm, control algorithms, control system, and sometimes integrating perception system like LiDAR. I also had the opportunity to work as an applied scientist intern. I worked there last 7 months over there in Amazon Robotics in Boston. And during that internship, I worked on warehouse robots and their perception simulations and their system that helps validate robot behaviors before they are deployed in real environments. So this is Amazon warehouse usually it look like, and there are, I mean, I cannot really tell the details about what I worked on because of the um, NDA, but yeah, we were working on small drones. They are convoying packages in the Amazon warehouse. So yeah, one interesting thing I learned is that there is an often a gap between simulation and real world robotics, and a lot of engineering effort goes into bridging that gap. So now I want to briefly share my journey. So I did my undergrad in Korea. So I came here less than 4 years ago. So my English is like still improving. Yeah, but I did my undergrad. I studied aerospace engineering. So you more focus on drones and fixed winged vehicles. But when I first looking for, oh, I want to do my PhD in the States, but to get a job after my PhD, like aerospace fields needs citizenship, which is I don't have. So I had to twist my journey to mechanical engineering so that I can work on the same thing, but it's like broader way opportunities. So during my undergrad, I became very interested in building things, hands-on stuff, solving engineering problems. And I participated in several engineering competitions, which gave me a lot of hands-on experiences. And competitions are actually a great environment to learn practical engineering because you need to design, build, test, and iterate quickly. It's like you are learning things theoretically, like theoretical ideas from school, but you're learning more from outside. During competition, I used to like learn a lot from YouTube. Yeah, that's that helped me a lot. And another important factors in my journey was meeting good mentors and advisors. So having advisors who encourages exploration and support your interests can really expand your perspective and open new opportunities. So for my case, was a I found really good advisor from my undergrad, and like whenever I try to like make my group of people, and then like I asked my advisor, I want to join, I don't know, like go this competition, and he was always supportive, giving me great ideas. Yeah, so finding good mentors are, I think, always important. And eventually, these through these experiences, I became more interested in robotics and autonomous systems, which led me to pursue a PhD in this field. Um, so this is like bunch of competition I attended. It's pretty loud, sorry. Here's like yeah, other oh, sorry, it's pretty loud. So this is what I did on my in my undergrad, and when I joined my PhD, they really liked my hands-on skills, and they were like, my PhD advisor, were like, hands-on stuff, everyone can do that. Like all the undergrads, they can do that, but what makes you different? Is from algorithm and theoretical ideas. So as a PhD, you need to like focus on more ideas, not hands-on stuff, because you can already work on hands-on stuff. So yeah, engineering competition that made me really improve my hands-on experiences, hands-on techniques. So engineering competition played a big role. And through this project, I learned many important skills beyond what you learn in textbook. So usually teamwork is extremely important. Complex engineering systems are almost never built by one person alone. And also, I learned system design, how different components like hardware, control, and software need to work together. And perhaps most importantly, competitions taught me how to turn ideas into real prototypes, and which is pretty important for like if you want to get a job in industry, like prototyping is a big thing for them. I mean, at least in robotics field. So the experience of building and testing real systems in is incredibly valuable in robotics. Um, okay. So this is kind of like my motivation I learned from my advisor. He's always like develop the technology that the world actually needs. So yeah, robot engineering is not just about solving abstract problems. It's more like practical. It's also about creating technologies that improve how systems work in the real world. So robotics has the potential to transform many industries, including logistics, manufacturing, transportation, and infrastructure. So that is one of the reasons I became interested in this field. It's like when you are working on a chemical engineering, chemistry, it's like really small thing they're working on it. But robotics, it's pretty big. You're actually changing something and then you're seeing the result in front of you. Yeah, I think that's pretty cool. So this is the lessons I learned. Not like build strong fundamentals like subjects like dynamics, control system, linear algebra, programming skills are extremely important foundation always. And even though robotics looks like very exciting, it relies heavily on these fundamental concepts. And yeah, always. And second, like do hands-on projects. Like if you want to get a job hands-on, like you want to develop something, it will benefit the world, then you need to do hands-on stuff. Like it's like I think basic, like bare minimum to join maybe robotics club, competition. If you want to do competition, so I was working as a part-time job to make some money to buy like drone stuff when I was in undergrad. I mean, it's too much, but if you can like fund it by your professor or like you can like get some money from your team or some competitions they fund you. So do hands-on stuff, embedded systems. And the third one is learn systems thinking. So robotics is not just a coding, it's it's about integrating hardware, software, sensing, and control into one functioning system. Yeah, and I've heard Brian is freshman, but I've seen freshmen already start their internship earlier. So pursue your internships early. Real industry experiences help you understand how engineering works outside of the classroom. Yeah, so and here's like good tip, I think. This is like description. I think this is Zooks. I had an interview with them today. So if you even though you're still freshman, like just get into like job description of like, oh, I want to be someone, I want to work for the company, then get into their website and then look for their career section and then see what they are looking for. That helped me a lot. So they're actually really specify like C++ or computer vision. They specified it so you can focus on it from it. Yeah, this is such a good tip, I think. Yeah. And yeah, that was all so far. Yeah. It's a brief overview of my journey and some lessons I learned along the way. Engineering and robotics are a very exciting field with many opportunities to explore different problems. And if you make really good progress or if you make something, then you can just apply it right away and the world will see your results. Yeah. Um, Thanks for listening. It was pretty quick.